Now we're going to come to the tricky matter of anti-differentiation. And most people can relatively quickly learn how and when to differentiate, but then get a little bit confused about when you need to anti-differentiate. If you can get over that hurdle, then most of the rest of calculus falls into place. Differentiation is the process whereby we went from a function to a gradient function. Anti-differentiation is the reverse. We take our gradient function and we get back the original function. For polynomials, which is all you need this year, the process is exactly the opposite of what we did for differentiation. Instead of taking away a power, we add to it. Instead of multiplying by the power to the coefficient in front, we divide, and we have to add in a constant of integration. Here's an example. If f dash of x, our gradient function, is 6x squared, then the original function must have been one higher power, and then we divide by that new higher power, and we simplify that. 6 divided by 3 is 2, x cubed, because we're adding one power, and then our constant of integration. One more time. If our gradient function is equal to a constant 5, then the original function must have been 1 power of x, and we divide by that new power. In this case, that just leaves us with 5x plus our constant. Whenever you do an anti-differentiation, it pays to very quickly work backwards to check that the differentiation works. In this case, 3 times 2 is 6, and I've taken away 1 power. 5x differentiates to 5. A lot of people actually differentiate by that way. They just do it what would it have been in order to get that gradient function. The constant of integration at the end, the c, is basically the key for most anti-differentiation questions and all the ones that achieve leveling. It comes about because any constant is lost when we differentiate. If I take a function, 2x squared plus 5, and differentiate it, then 2 times 2 is 4, and I lose 1 power, and my constant disappears. If I take a very similar function, 2 times 2 is 4, and my 3 disappears, I get exactly the same gradient function. So I can't tell, once I've differentiated, what my constant was. And that's what the plus c means. It is that unknown constant. And we find it by using a point on the original function. Here's an example. If we're given a gradient function for a function is that, and we are told that the function of 1 is 9, what was the original function? Then we anti-differentiate because we've started with a gradient function, and we recover our original function. It's 2x cubed plus 5x plus c. Add 1 to the power and divide by 3. Add 1 more power and divide in this case by 1, and there's our c. But we're told that the function of 1 is 9, and since we know from the anti-differentiation that the function is equal to that, we can combine them together. The function of 1 is equal to 1 put into that expression, and it is equal to 9. We solve that, and that gives us that c is equal to 2. That doesn't answer the question. The question was, what was the original equation? So I put my c is equal to 2 into my anti-differentiated version, and that is my answer. I know it's right because if I differentiate that, I get 6x squared plus 5 as my gradient function, and if I put function of 1 into there, my answer is 9. Do another one. Find the graph that passes through 2, 6, whose gradient at any point is given by 5 minus 4x. We are told in effect that is our gradient function. Whose gradient at any point is given by that is our gradient function. We anti-differentiate that, and we get the original function. Add a power of x and divide by its power, divide by 1, at a power of x, so we put x squared and divide by the 2, and then our constant. We're told that it passes through 2, 6. Now that's the same as saying that the function of 2 is 6, because our points are x, function of x. Recognising that is the key to most of these questions. So we know that the function of 2 is equal to 6, and the function of 2 is also equal to 5x minus 2x squared plus c. Put 2 in, and we solve. It gives us c is equal to 4, so we can write our expression for our original function. The function was 5x minus 2x squared plus 4. So to differentiate that, I get 5 minus 4x. If I put 2 into it, I get 6. Whenever you anti-differentiate a question, always pay attention to where they've told you the original point. They can give it to you in function of x is equal to this, or they can give it to you a point, or they can, if they're being particularly mean, give it to you as an intercept or something like that. But they will always give you a point to fix that original graph. So when do we anti-differentiate? Whenever we start the question with a gradient function, but it can come in various forms. You can be told it as the gradient function, or dy by dx, which is the same thing. You can be told in words what the slope is at any point. You can be given it as a rate of change in some quantity, which is just a gradient by another name, and you can be given it in some merit questions as a velocity. Doesn't matter. We anti-differentiate when we start with a rate, and we want to end with the original quantity.